Hello, everyone. I'm excited you joined me for an investigation of unconventional wells and hydraulic fracturing sand consumption in Colorado. My name is Erik, and this year I got to work with the Mines Undergraduate Research Fellowship under my mentors and a peer, Dr. Smith, Dr. Duzgun, PhD student John Sue, and Christina. To provide some foundation for the reason I undertook this project, I want to share some background about how frac sand became the focus and why it's such an interesting commodity. So recall that in 2015, the United Nations published 17 guidelines for sustainable development that its member nations and their extractive industries adopted. However, 8 major oil and gas companies had poor reporting of their transport and logistics, with an average of 13% being recorded over an 8-year period. Since sand is an aggregate, it has a high sensitivity to transportation distances. Silica sand specifically comes from a few primary sources in the United States, as it has some particular characteristics that make it more desirable in fracking operations. Since it's cradle to grave, life is straightforward. Silica sand would be the starting point for understanding more about the SDG reporting process in oil and gas. As a quick reminder of its application, silica sand is used in the hydraulic fracturing of unconventional wells. These wells are in reservoirs that have a low permeability and struggle to produce economically without having additional work done to them. So hydraulic fracturing itself is the method of injecting water and chemicals underground at high pressure to create new fractures and then improve conductivity within that reservoir. However, there is some significant pressure placed upon these reservoirs. It's up to 10,000 psi in some locations. Without anything to keep it from collapsing, these fractures would just close up. This is why the frac sand is so important. It can prop open these fractures to prevent their closing. To do this, frac sand needs to be selected with some specific characteristics in mind. Natural frac sand is monocrystalline. It has a high silica content and a high sphericity. This gives it the strength to resist those high formation pressures, but also the ability to travel downhole when carried by a fracking fluid. So that leads to the objective of this research: to connect the frac sand consumption of these unconventional wells in Colorado to the respective quarries. This was broken down into 3 major goals, right? To review the relevant literature, identify the location of unconventional wells within Colorado's borders, and then finally to connect these wells to the respective primary producers or quarries. My literature review showed that frac sand is unique in that it's sourced from a few principal locations with the United States, but the connection between them and their means of transportation is not always so well delineated. Northern white, or Ottawa sand, comes from the Wisconsin, Illinois, Montana area in the northern United States, but Brady Brown comes from Texas and Oklahoma in the south. There are 2 types of silica sand most frequently used in the United States, but they are supplemented by synthetics and resin-coated proppants. These synthetics make up a small percentage of the total mass used, however. Again, sand is very sensitive to transportation costs, and you can see its price increase substantially based on the method of travel used. So to achieve goal 2, I started by finding an appropriate data source. This was challenging in and of itself because reporting is not consistent across the country. Proppant usage is not publicly recorded, and USGS estimates for silica sand consumption in the United States do not differentiate between silica sand mined in hydraulic fracturing versus other industries like glass. Ultimately, Frac Focus was selected because operators in Colorado recorded their proppant usage, which could be correlated to a specific well over a time period. Using the equation on the bottom of the slide, we could estimate the amount of sand used in each well over this time period. It's important to note that the information uploaded to Frac Focus may contain the same information that the operators provide on their permits, but they're not required to upload this information. It is a voluntary upload. Okay, so now this is an image of an interactive map that we created plotting the unconventional wells of the 2012 to 2020 year data set. The light gray regions that you see, the wells or those points are known as shale plays or unconventional reservoirs. There are about 30,000 wells recorded over this 8-year period that are associated with proppant usage. These wells are categorized by consumption, and here you can see the spatial layout of these wells in Colorado specifically. You can see how the majority of them are centered in or very close by these reservoirs. Ultimately, what this process made clear is that 99.3% of the wells were identified to use less than 3.12 million tons of frac sand, and that there was a large difference between the consumption of these standard wells and the largest well. the well with the largest sand consumption reported used approximately 12.5 million tons of sand, while the standard used far less, not topping over 3.12 million tons. Overall, about 200 wells of the 30,000 were considered outliers. Using the same data, I generated a heat map of the average sand consumption through Colorado during this time period. The highest concentrations appeared in the northern area, but there is some higher consumption in the west as well. Overall, there were 63 unique suppliers found in Colorado. The largest was Liberty Oilfield Services, Halliburton, and Anadarko, which made up about 67% of the supply in Colorado. Unknown or unspecified sources constitute slightly more than 20% of the supplied sand, while the remaining competitors, about 60 suppliers, made up the remaining 11.8%. So once this map was generated, it became clear that there were a multitude of issues surrounding the data set, and more importantly, the lack of supplier-side data. The quarrying and transportation of sand is relatively straightforward, right? The challenge surrounding frac sand is how to transport it as effectively as possible to reduce both the price and the environmental impact of moving such a large volume of material. This is mostly handled by the suppliers of the sand who harvest the commodity from those three principal sources we discussed. However, there's a lack of supplier-side data. The publicly provided frac-focused data does have some excellent information, but it highlights the lack of transparency involved in the specific supply chain. Unknown suppliers or the unspecified amount of material frequently obfuscate the total amount of sand consumption in Colorado. Moreover, the provided data was of poor reliability. One particular well recorded that it consumed 12.5 million tons of sand, and that is implausible. Speaking to industry experts that work in Colorado, the estimated sand consumption of an unconventional well could be between 5,000 and 15,000 tons of frac sand, which is several magnitudes lower than what that particular well reported. Most wells do not report such huge numbers, but about 200 did from that data set, and those were far above the estimated average. So this just hammers home that the issue with this particular set was that frac focus was designed with an emphasis on water consumption and chemical consumption, not proppants. So it struggles from that inaccuracy. Consequently, the combination of unconventional wells with no proppant use recorded or very high amounts recorded skews the rest of the data we use and makes evaluating adherence to the United Nations Social Development Guidelines for transport and logistics much more difficult. So in conclusion, the big takeaways we can derive from this research is that there's a difficulty in seeing the impacts of this supply chain because of the gaps in supplier side data. If we can make this process more transparent, then we could develop a stronger understanding of the economic and environmental consequences of the logistics of frac sand. Moving forward, some ways we could try to tackle this problem would involve using estimates of USGS silica sand quarry estimates to help us massage a supplier side data gap. Using this and some general assumptions about the major supplier quarry locations and the methods of transport use, we can kind of begin to backtrack and make this process more transparent. So anyways, finally, I want to thank you again for joining me on this quick look at frac sand in Colorado. I'd be very excited to hear any comments, suggestions, or criticisms you have to share in the forum below. And again, thank you.